social studies teacher why we as a nation have the Electoral College put in place. Just curious what your social studies or your history teacher or your American government teacher will tell you. Sound like a deal? Pretty easy? Yeah. Okay.
Isn't it because that we were just the average populace was uneducated and didn't have a good culture?
There you go. You nailed it. We are too stupid as people to actually vote for a president. So they thought the smarter people who would cast the Electoral College vote should be the ones to elect our.
Do I still need to ask my teacher that question?
Go ahead. Just see if you get that answer out.
Right.
But that's the exact answer. Good for you for knowing that. Love it. Okay. Let's go through the homework a little bit, see how we did. That one on. Yeah. Did we? Oh, you want to see 64? Yep. All right. All right, number 64. Problem number 64. You have. So we have a dot there, we have a dot there, open dot there, not a dot there. Okay. All right, problem number 64 says this. Determine the domain and range of the piecewise function, then write an equation of the function. Okay? How many linear functions are on this graph? 3. So there's 3 lines that are going to take place. So I know that my function should look like this, function at x or function of x or g at x or h at x, however we want to say this, is going to have 3 equations that are going to take place. Now, if I have this one as a red line, I'm pretty sure I can figure out the domain of this red line. They're both closed dots, so they'd be square brackets. Would you agree? Okay? Now, being that this dot right here is shared between the 2 lines, you have to pick. Do you want the first red line that we have up there to be the one that has the square brackets, or do I want the other line to have square brackets? There's not a right or wrong answer. You just have to choose one of them to be square brackets. Okay? So it looks like, if I look at number 64 correctly, that it goes from -4 to -1. Okay? So that's in the x direction of my red line. I chose to have my information as a square bracket, which in this case I have as the equal sign, less than or equal to, take place. So that means that if I use this -1 down here on the next line, it has to be just the less than sign. It can't be the other one. So the other equation, take green right here. So green right there is going to go from -1 is less than x, and it goes up to an open dot. If it's an open dot, and it looks like 2 in the x direction, it's less than 2. So the less than sign is going to mean, hey, we're not including that endpoint. The 2 is obvious because it's an open dot. The one that's a shared dot, I have to choose. Do I want the top equation to have the less than, or do I want the bottom equation to have the less than sign? Okay? You get a pick. It's not one way or the other, guaranteed. And then the last problem is the black line. We'll keep it as black. So this is going to go from 2. Actually, go to this. It's going to be x is greater than or equal to 2. Because it's a solid dot because of that right there. Okay? My domain is now set. My domain's now set. Okay? So the black line equation is y equals what? The black line equation is y equals what? 2. Just the number 2. This means it's a horizontal line going across 2. It has a slope of 0. right? Go to the green. Go to the green. Okay, so we have 2 points that are given. When I look at that green line, can I see where it crosses the y-axis? What do you think? Can I see where my green line crosses the y-axis? I see that it crosses it, but if you look at your original graph, can you see where it crosses? No one has a book open. Good. It actually crosses here at -1. Do I know a y-intercept? That's b, right? So if I were to use the equation y equals mx plus b, I know that my b has to be -1. I have 2 points given. If I have 2 points given, I can determine the slope. Remember, the slope is m. The slope is a map. So if I go from the bottom dot to the top dot, it looks like I'm going to go up 1, 2, 3, over 1, 2, 3. So I get 3 over 3, which is 1. So y equals 1x minus 1. That's the equation of our green line. Okay. Now, if I did not know exactly where across the y-axis, I can't go that simple. I have to use the 2 points, go through by the slope. Once I have the slope, then plug it back into the point slope, which is the y minus y1 equals m times x minus x1, at least the popular. Okay, so red line is this. Red line's this. I have 2 points given. It looks like I have -4, 4 as 1 point, and I have -1, -2 for the other point. Is that okay? So here's our 3 steps. First step here, so let's find the slope. So y2 minus y1 over x2 minus x1. Algebra 1, very simple equation to use. Always forget it. I guess you could have labeled this x1, y1, x2, y2. Plug in your information. So I get -2 minus 4 over -1 minus 4. So I get -6 over 3. So my slope is equal to what? -2. Then I'm going to use point slope. Y minus y1 equals m times x minus x1. This is just a modification of the slope equation above. Least popular to use because, well, it's got too many variables. So I'm going to take my x1, y1, plug it into my slope. So y1, we called 4, so I have y minus 4 equals -2 times x minus x1, which is -4, so -4 plus, distribute. So y minus 4 equals -2x minus 8. Add that 4. So I get y 2x minus 4. That's the entire problem. A lot to it. Okay, a lot to it, but I think if some of the things that you realize are simple, it's pretty easy to find slope counting from point to point. Obviously, if it goes towards the right, it's a positive slope. If it goes to the left, if it rises to the right, it's positive slope. If it rises to the left, it's a negative slope. If it's horizontal, it's going to be a slope of 0. What else do we have as far as the homework went that you have a question about? 45? Absolutely. 45. 45 says graph each of the following. Okay. Problem number 45. So they're using g at x. Does g of x mean the same thing as f at x? Yep. 1/2 x minus 1. 3. -2x. There's all the chat going on. Okay. So we have, as piecewise function, we have some restrictions. We have how many linear equations that will be drawn? 3. I feel the easiest way to draw all 3 is draw the whole thing and then erase what you need, or what you don't need, excuse me. Okay, so I'm not going to worry about the inequality at this point. So I know that 1/2 x minus 1, I will do this one as a blue line. So I get negative 1 here. From there, I'm going to go up 1, right 2. And I'm going to draw myself the entire linear equation, how I draw it, just in Algebra 1. The next one I'll do as the red line. What kind of line is that other than straight? Horizontal going through what? 3. So I got 1, 2, 3. Let's pretend I can draw straight lines. Okay. And then my last line will do green. What's the y-intercept of that line? 0. What's the slope? So I'm going to go down 2, right 1. And again, I'm drawing my entire, all 3 lines. Okay? But I only need a portion of each of the lines. So now let's figure out what the portion we need. So back to the blue line. Back to the blue line. I want less than 0. So I'm just talking about to the left of the x-axis. Do I want it as an open dot or a closed dot for the blue line? Open. Why is that? There's no equal sign. So I'm going to erase all of this. I don't need this. And I'm going to make this dot open. Okay? Blue line's done. Let's go to the red line. I want between what and what? 0 and 1. So if 1 was here, and it looks like I'm going to have a closed dot here, as well as a closed dot here. And I realize it's blue, but I think you get the idea. I'm going to erase the rest of that line. Okay? And then as far as the green goes, I want greater than 1 in the x direction. So it's going to be an open dot right here, going that way. I'm going to erase the rest of it. There's our piecewise function. The reason I can call it a function is I can draw the vertical line test. It's not going to intersect it more than once each time I draw it. That's the difference between the open and the closed dot too. Open dot means you're not including that. Closed dot means you are including it. Any other questions from the assignment? You okay about it? I will tell you that come next week, what did I say, on Wednesday and Thursday next week, we will have a 2-part test. One will have no calculator, meaning the graphing calculator. If you have the 4 function, you add, subtract, multiply, and divide. I'm totally fine that you use it. Don't come in with the graphing one saying, can I use this if I just add, subtract, multiply, and divide? The answer's got to be no, because I can't make sure that you're not plugging extra stuff in. Okay? And then the other one, you do need to have that graphing calculator on. So Wednesday will be non-calculator, Thursday will be calculator. Okay? And yes, I will have a couple of calculators for you to borrow. Okay? Can I collect homework? And I'm recording. So, if I have 2 equations and I added those 2 equations together, what are some things you might think would have to take place to add 2 equations together? What's something that might stick out to you? And if I were to add 2 equations together, how would I do it?
Combination.
Combine like terms. What would a like term mean to you? I can't combine x squared and x because one's a higher power than the other. I like it. What else? If I was adding 2 equations together, what else needs to take place? Like terms, which is the same exponent, same exponent. Yeah? Okay? If you're just adding them together, the exponents don't increase when you're adding like terms together. Okay? Obviously, it's the same letter have to add together. So you could add a 5x and a 7x together, but you couldn't add a 5y and a 6x together because they're two different letters. Those would have to be the same exponent. Now, if you're subtracting exponents, same idea. Like terms are the same letter and the same exponent can be added or subtracted. If you multiply, then you multiply. You multiply them, the exponents will increase. You're changing dimensions when you multiply. Okay? And the weird thing is I said the term dimensions, and the thing is you know that length, width, height for the most part. You get the one kid who paid like 5 minutes worth of attention in science and thinks that time is also a dimension. It's actually a half dimension because we only can go forward in it. But a dimension is defined as something you can go backwards and forward in. Okay? Do you all know that if you were to take a source and you were to create a shadow, the shadow is a dimension less than the dimension you are in? So if you were to shine a light source on a three-dimensional object, you'd have a two-dimensional shadow. Does that make sense? Yep. Oh, let's go deep on this. Okay, so wait a minute. If I cast a shadow that's two-dimensional, and I'm a three-dimensional object, so my shadow, right there, my hand's 3 dimensions. You know what? My shadow's 2 dimensions. What would my shadow's shadow be? 1 dimension, which is an infinitely small point in space. Let's go the other way. So my infinitely small, one-dimensional shadow of my hand shadow becomes the shadow of my hand. Increase the dimension of my hand shadow, and you have my hand. Increase the dimension of my hand. What do you have? 4th dimension. If I take that 4th dimensional object, and go 1 dimensional higher, do you know what your hand looks like in the 4th dimension? I can tell you what it looks like in the 3rd dimension. This is the shadow in the 4th dimension. Okay? What does the 4th dimensional object look like? What does a 5th dimensional object look like? What does a multi-dimensional object look like? Oh boy. You want me to show you? Yeah. Oh, okay. Alright. You guys ready for this? I think this is a little off task, but believe it or not, I get off task from time to time. I know you just think I'm funning you on this. Alright. Okay, pretty sure most of you have drawn something like this. Yes? In fact, some of you are probably in the middle of drawing a box right now because you're bored, it's waiting to pass time, and then you draw that. Are you still with me on this? Yep. Does this make sense? Yep. Okay. Is that a 3rd dimensional box? Yes. Yeah. Your question, is it a 3rd dimensional box?
Technically, no.
Why?
Because it's not actually there. It's just a drawing of a 3rd dimensional box.
Okay. So, why is it 2 dimensions?
Because it's on flat.
It's flat. Good. Good. So you are representing a 3D box in 2 space by drawing that. I'm pretty sure almost everybody here has drawn this before. Now I'm going to highlight this. Let's see if this is going to work. I'm going to copy this, and then I'm going to paste this. Still with me? Okay. Now I can move this object, supposedly. Start to move. All right. I'm going to do this. I'm really going to put a few twists in life. Let's move it to here. Still with me? So now you have 2 represented models of a 3-dimensional object that is being portrayed in 2-dimensional space. Now, if I were to give you, some straws or toothpicks and some bubble gum for the corners, could you make this? you make that shape? Okay, let's go a little bit beyond. Ready? You're already beyond us. You're right. I'm going to connect this to this. Still with me?
No.
I'm going to connect this to this. You still with me? I'm going to connect this to this. I'm going to connect this to this. This vertex here. I'm going to go back here. So here. I'm going to go here. And then I'm going to go here. That right there is a shadow of what the fourth-dimensional object would look like in two-dimensional space represented in a three-dimensional environment. Now we're going to lose everybody. Ready? I'm going to copy. I'm going to paste. I'm going to bring this over yonder. Yeah, we'll do it. Why? What? Who? Where? What, who? So now I'm going to connect that to that. And I'm going to connect this to this. This to this. This to this. And I'm going to continue to attach all the appropriate vertices to then show you what a fifth-dimensional object shadow in fourth-dimensional space would look like in third dimension, cast in the second dimension. If I did 6, all I have to do is continue to connect all those vertices, do a copy and paste, and then connect all the appropriate vertices. Okay? Unfortunately, that's not necessarily where our lesson needs to go, but theoretically, this is what's going to go. Here's a frightening term. Here's a frightening term. In the world of science, there are 9 dimensions that they know of. And we only taught you a third of them in high school and elementary school. Okay?
Wait, are you sure?
Huh?
Because in my philosophy class, like, our teacher was talking about how there's no way anything further than the third dimension.
It's represented in fifth dimension there.
But it's not actually.
It is. But could you make that object in 3 space?
If you could give me
What'd you
some
think?
example.
Think about it. Think about if I had a clear box in which you saw all the edges and all the corners. Still with me? Just think about with straws. Can you do that? So you think about that 3D box. Create that other 3D box, and then connect all the appropriate vertices.
In class, when we did that with like a Lego house, it was like we all had to build up I don't know which theory it was. It's like it had to do with science.
Absolutely. I'm just showing you mathematically. Using the whole world of geometry, it'll make your mind go crazy. All right. So, how, if I had this, let's do this. Let's go actually to the lesson. If I were to take the function at x, and if I were to take g at x, okay? If I were to take the two of those, if I were to add them together, if I were to take f at x plus g at x, I could take 3x squared, doesn't add to anything, plus 2x minus 3. Does that make sense? If I add those two things together right now, I'm going to get 3x squared plus 2x minus 3. Yay or nay?
Yeah.
Same idea if I were to subtract them. Same idea if I were to multiply them. You use the 4-letter F word, FOIL. You could FOIL those together because there's two terms. You could, what would this be though? What would this be? I know. I just kind of, I wowed you guys with dimensions. I'm sorry. Shh. What would that be? F at x divided by g at x. Say it. There you go. 3x squared plus 7 over 2x minus 10. That's basically as far as you need to get to this point, other than saying that x is not equal to 5. Why do I say that? That would make the denominator 0. But if I were to divide those two fractions together, you'd have to tell me what the restriction of the domain would be because of the denominator. Almost done. Almost done. Let me erase this. I know you guys are getting all mad at me, but Let's deal with it. Is this going to work this time? At least get stuff out of the way. There's my eraser. All right. What if I were to, I'm ignoring this down here. Shh. What if I did this?
F times G of 2.
What do you think? Any ideas? You what? No, I'm just multiplying them together. I'm not plugging it. It's supposed to be times. What? So close? Love it. So it was said. It was said. Let's plug into this. If I plug that 2 in, what do I get? Negative 6?
That's what I said.
Almost. Where is my x right here? What is x representing right there? 2. What happens if I plug 2 in here? 19. So I'm getting 19 times negative 6, whatever that answer is your answer. Here is your assignment. You should be able to play with this. Today's Wednesday, don't lie, right? Page 116, 61 through 67, odd. 81 through 85, or 81, 84, and 85. And if you don't get that, it'll be on my spot. Hey, if you're watching this, you'll realize that you already did last night's homework last week. So just bring your books to class tomorrow, and we'll take care of that. So my mistake. Have a great day. See you Thursday.